later. Let's try this one. Okay, so now we want to talk about functions and models. So what does that word mean, model? What does model mean? Anybody ever use that word in English? Okay, no, I don't want to look it up on Google, but what does model mean? Can anybody use the word model in English? No? No? What? Not so sophisticated. Just use it in English. Just use it in a sentence, the word model. Make a sentence that has the word model in it.
Supermodel.
Supermodel, good. Another sentence. Another sentence. Can't make a sentence that has model in it? Okay, how about like model airplane, model car, model something like that, right? Let's take model airplane, okay? So I don't mean like supermodel. I don't mean model like someone that walks down that's showing clothes, but the other word model. So a model airplane. So when I say something is a model airplane, what does that mean? Means what? Imitation. Right. An important part of the fact that it's a model airplane is that it's not a real airplane. Right? It's not a plane that you can actually fly from here to Tokyo in, right? Right? Okay? So a model is different than the real thing, right? That's one of the ideas behind the word model. Okay? Does everyone understand? Now, how about, have you ever heard this, that we have an equation which models the economy? Like an equation which models the economy of Japan. So what would that mean? First of all, an equation means that there are variables, right? Equation means that there are variables. So we might have like the GDP is one variable, okay? And we might have time is another. I'm just making it up, but okay? For example, okay? So we might have, just to make it super simple and not realistic at all, but suppose we just had that, okay? So what is that? That says that what? As T increases, what happens to the GDP? It also increases, but in this case I'm saying it increases as the square of T, which would be, crazy, right? Super increasing economy, but just made it up, right? Okay, so that's an equation that we might say that models the economy. So what did I say? What's the difference between a model airplane and a real airplane? The model is not real, right? It's not the real airplane, right? So when I say this models the economy, what do I mean? It only it's only an imitation of the economy, right? It's not perfect, right? It's not exactly the same as the economy. In other words, I don't really think, no matter what equation I write here, even if, obviously it's not T squared, but no matter what equation I write here, I don't expect it to be perfect, do you? Do you think I can ever write down a perfect equation for the GDP in terms of time? Right? I doubt anybody feels confident in this world to do that. A lot of people that might sort of, they make a business out of doing that. And they say, well, here's a model of what's going to happen next year. And maybe people will believe them, and they might get consulting business out of that or something like that. But anyway, we don't really believe that we can say exactly what's going to happen, that we can write down exactly the relationship between time and GDP. That's why we call this one. So things didn't follow anywhere near the model that many people were using in the stock market. So, you know, if you follow it too carefully, you really believe it 100%, probably you might pay a price for that at some point. Okay? Does everyone understand? Okay, let's take a look at this. So the temperature, let's see. So what do they say? To mathematically model a situation means to represent it in mathematical terms. The particular representation used is called a mathematical model of the situation. So the particular mathematical model I used there was t squared. Okay? Mathematical models do not always represent a situation perfectly or completely. Quick examples. The temperature is now 10 degrees F now, so in this book they use Fahrenheit. But anyway, and increasing by 20 degrees per hour. Model. T of T. Now there's two T's here, which is unfortunate. But what's the capital T and what's the small t? Capital T is what? Is what? Yeah, right, it's the function, but what does it stand for in this particular example? The temperature, right? And little t is what? Time, right? So unfortunately there's two t's there. Anyway, that's just a coincidence. But t of t equals 10t plus 20t, right? So that tells us what? That when t is 0, when little t is 0, what is the temperature? 10. When little t is 1, what is the temperature? 30. When little t is 10, what is the temperature? 210, right? Everyone understand? Okay. Okay, here's another example. I invest $1,000. Invest, like put it in the bank, for example, at